We did not do these last week, so we're going to do 6, 8, and 9 today, and we'll say what should be number 11. Why it's number 1 again, I don't know. Number 11 for tomorrow. We took a test yesterday. Some of those are graded, some of those are not. Regardless, we had problems similar to this on the test, so I wonder why it's coming back up today. I wonder why our notes are still on it today. Apparently there's more to learn about this. And why did we go ahead and do 7 and 10 the other day? Why did we do 7 and 10? So were some like 6, 8, 9. Why 7 and 10? Why did we get them out of the way? They had an index, yes, they had an index of 2, so 5 gets the point. They had an index of 2, and we practiced a lot with 2s, so that's why we went ahead and do them. We haven't spent as long on 3s and 4s, and then I don't know why we're being so lazy, not you, like math people in general. Like, why are we only doing, y'all practicing ones with 2s, 3s, and 4s? The index could be any number. It could be 10, it could be 5, it could be any number. Why are we sticking to 3s, 4s, and 5s? I mean, 2s, 3s, and 4s. I don't know. Well, I do know is because we assume you don't know like what 2 to the 6th is, but my goodness, you have a calculator in your brain. You could figure that out, but I digress. Again, things that I need to keep inside my head. Okay. We're actually going to do number 8 first. It's the easier option. And plus, I lied to you the other day, and I need to fix that lie. Well, I lied for good cause. It was just too many things going on at once, to tell you the truth. Okay, so number 8. We would love to solve this problem. What do you think the answer should be? Yes, and I'm going to give, I know Karen said it. I don't know who else said it. Again, I'm just trying to do math today. So Karen gets a point. If you said no real roots, you can give yourself a point. And then that's the lie I need to fix. That's the lie I need to fix. So that's actually not true for this problem. So I told you anytime there was a negative under the radical that we were going to put no real roots because why? What were we going to have to involve? I, and we didn't want to involve I. I know I heard Jax and Ellie say it, so they can both have a point. That's actually not true. It depends on this number. It depends on the index. If the index is even, then you are right. There are no real roots. If the index was an even number, like 2, 4, 6, 8, 10, and there was a negative under the radical, then you would be right. There would be no real roots. That would be a correct statement. But sadly, odd numbers have a mind of their own. So, for instance, negative 2 to the second is positive 4. But negative 2 to the third, that's not positive 4, it's negative 8. So we can actually get real numbers to give us negative answers if it's an odd index. Okay, so saying all that, this problem actually has a legit answer. Let's do the easy part first. X minus 2 should be raised to the what power? Yes, and you can have a point if you said 4 because 12 divided by 3 is 4. And then I need to know the cube root of negative 27. So what to the third power gives you negative 27? It is not, it's going to be negative 3. Yes, Ellie. Ellie gets the point. Because we want a negative 27, so it's a negative 3. Again, I know I lied with good cause. It's like when your mom and dad lied about Santa Claus. I swear it was all for good reason. I mean, moving on with our lives. Cooper. Okay, moving on. I lied with good reason. I knew eventually we were going to have to deal with this. And last week there were so many other things that were so overwhelming that we just need to let it go. So if it's a negative index, if it's an odd index, it might be okay to have a negative under the radical. Okay, so 8's done. Let's deal with 6 and 9. Okay, 6. There's a 3 on the outside. I'm going to leave him there. X to the what power? Yeah, and that gets to come out. And then, does anyone know the cube root of 16? No. That's not our final answer, though. We can do better. Now, lately, and on our test for sure, we had perfect, pretty problems. Like, it would be 8 because 2 to the third is 8. Or it would be 27 because 3 to the third is 27. We had pretty perfect problems, and in reality, that's not how math works. So when we used to take the square root of a weird number, like the square root of 8, we would think through what multiplies to give me 8, and one of those numbers had to be a perfect square. So we would end up breaking it down like this. We need to have that same logic, but instead of perfect squares, because our index is 3, we need to think through our perfect cubes. So what times what gives me 16? And I need one of those numbers to be a perfect cube. Like, I get 1 and 16, but neither of those are perfect cubes. 8 and what? 8 and 2 would be perfect. I heard someone else say 4 and 4. 4 is a perfect square, yes, but our index is 3. We're needing a perfect cube. So what's going to come out and what's going to stay under the radical? Yes, a 2 is going to come out and a 2 is going to be under the radical, but I'm going to write that for those of us who are like, what on earth? So it's going to be like this. We said it was 8 and 2. I know the cube root of 8, it's 2, so I'm going to bring out that 2. Have a cube root of 2 left, because the cube root of 8 is 2. And then 3 times 2 is 6, so my answer is 6x squared, cube root of 2. And if you're like me, I kind of like it when the variable's at the end, so I would probably write it as 6 cube root of 2 x squared. But if you write it like this, you have to be careful, because you want to make sure that radical symbol doesn't go over the x squared too, or else you've messed up everything. Okay, if you have no idea how on earth Jax helped us go from 16 to a 2 coming out and a 2 staying in the radical, if you don't know your powers of words, English, jeez. If you don't know your perfect cubes, English, Jesus. If you don't know your perfect cubes, it's okay. We could do what you used to have to do in middle school, or before that even, where you had to break it down, like 16 into prime factors. So 16 is 8 and 2, 16 is 4 and 2, 8 is 4 and 2, 4 is 2 and 2. And once I break it down into prime factorization using like a factor tree like I did, you could say, since my index is 3, I need to have 3 of them. Since I do have 3 of them, that's why 1 gets to come out. And then that guy doesn't have a friend, that's why he has to stay at home. So if you're not understanding Jax's logic of he already understood 8 was a perfect cube, then this is a good suggestion for you. Okay, and then we've got to deal with number 9. There's already an x on the outside. The y is easy. It's y to the what number? Yeah, because 16 divided by 4 is 4. So that part's easy. And so we need to deal with that 32x to the 5th. So again, I'm needing 2 numbers that multiply to 32, like 1 and 32, but I need one of them to be a perfect 16 and 2. If you know you know 2 to the 4th is 16, that's perfect. Okay, so Ellie knows 2 to the 4th is 16. I just happen to know 2 to the 5th is 32. I don't know. Eventually you start seeing these numbers over and over again, and it just starts to click. So I already understood that. The way Ellie understood it was 2 to the 4th and 2. But worst comes to worst, Seth can always list it out. So 32 is 16 and 2. He can break 16 down to 8 and 2. He can break 8 down to 4 and 2. He can break 4 down to 2 and 2. He needs 4 of them because the index is 4. So 1, 2, 3, 4. He knows A2 gets to come out. Out of the 4. He knows A2 gets to come out. He knows another 2 is left at home. And I forgot to write my index on that, which is bad. Okay, so we dealt with the y's. We dealt with the 32. We've still got to deal with that x to the 5th. Okay, so in the x to the 5th, 1's going to come out, and how many are going to be left in? Yes. So if you want to do it, you could do x to the 4th, x to the 1. So you could break it up like that, because x to the 4 plus 1 is x to the 5th. That's the same thing. I know 4 divided by 4 is 1, so I understand that an x gets to come out. So we had xy to the 4th, a 2. I understand an x gets to come out. A 2 still left under the radical, and I still have the x to the 1 under the radical. But again, if you have no idea what's going on, x to the 5th, you could write it out. So there's my 5 x's. My index is 4. I need 4 of them in order for someone to get to come out. That's why 1x gets to come out. That's why 1x is left at home. There weren't enough matches. Okay, so if I write my final answer, it should be 2x squared, x to the 1, x to the 1, that gives me x squared, y to the 4th root of 2x. So we think we're like getting this beautiful answer, and it's really ugly as can be. But 2x squared, y to the 4th root of 2x. Okay. And that's what we're doing today too. So you picked up your notes on the way in. It looks like the thing we just did in math workshop. So let's look at the 6-5 operations. So we need to cover 6-5 and 6-6 as quickly as possible because there's a test after 6-5 and 6-6. Well, actually, the last 2 sections we're going to cover in chapter 6. And then we move on to chapter 7. And I would really like for us to test, well, no, that's not true. I really wish I could have this kid any minute now. But our goal was to have this next test in before I leave you. So that was our hope. And that can continue to be your hope. My hopes have changed. But anyway, so we're going to try to hurry through 6-5. 6-5 has some guided practice problems, like the 1, 2, and 3. I'm actually going to say we can skip those. If you want to do the 1, 2, and 3, you can. But we're going to skip those. In fact, we're going to do the top 4 problems. Then I'm going to give you a checkpoint, and you're going to do the checkpoint as a group, meaning everyone in your group works on it. Last period, I had some people not understand this whole as a group. They just relied on one person to do it, and they're not getting their points. So when I give you the group checkpoint, it literally means as a group. Not just Ellie does it, but like Ellie, Gilberto, everybody in the group works together. Anyway, we're going to do a group checkpoint on this top little bit of 6-5. Let's look at number 1. This one's going to be an easy one. Can someone tell me the answer? It's definitely an x to the 4th. Yeah, because it's an understood index of 2. 8 divided by 2 is 4. So Gilberto has that part. Let's deal with that 32. 16 and 2. So what should have came out? A 4. So it should be 4x to the 4th square root of 2. Or again, if you want to write it as 4 square root of 2, x to the 4, it means the same thing. Just make sure the radical is only over the 2. But the reason he knew that is because he's thinking through 16 times 2. I know the square root of 16 is 4. We've been doing the ones with an index of 2 for a while, so 1 and 2 are supposed to be easy. Okay, so we're done with number 1. It was easy. Now we're on number 2. The c to the 6 is easy. How many c's come out? Yes, and you can have a point if you said 3. Now someone tell me about the d's. Okay, we have dealt with this for a while. Why does 1 come out and 1 stay in? That's completely correct. But why does 1 come out and 1 stay in? Three doesn't divide into 2. And so what were we doing instead? Yes. So, and so I have two different logics. We've either been doing circle bunnies, so like d to the third was this. So our index was 2, so we had the circle bunny, so the 1D got to come out. That one didn't have a match, he stayed home, so you could do it like that. Or you could do it the way Paige was doing it, which is really helpful for today. She understands d to the third is really d to the second, d to the 1, because 2 plus 1 is 3. She can do 2 divided by 2 and get 1. She knows this one's never going to work out, and that's why he's left at home. That's genius. So we talked about backing down. Like d to the third isn't divisible by 2, no, but d to the second is. And that's what we're going to do on the next problem as well. So like 8 is not divisible by 3, but we can back down to a number that is divisible by 3. Okay, but before I get ahead of myself, we still haven't dealt with the 12. We dealt with the C, we dealt with the D, we got to deal with the 12. 4 and 3 are 12, yes. Jax, you're very good, you're perfect squares. So a 2 gets to come out because I know the square root of 4 is 2. A 3 gets to stay at home. Again, it's because I know the square root of 12 is the square root of 4 times 3. I know the square root of 4 is 2, so it's 2 square roots of 3. That's how I knew to incorporate them where they are. So my answer is 2c to the third d, and then the square root of 3d. But again, 1 and 2 were supposed to be easy because those were indexes of 2, and we've been dealing with 2's for a while. Now, have our problems lately been perfect ones, like exponents that are divisible by 2 all times? Yes. We've finally come down to reality, yes, but we've done these before. 3 and 4, where life's gonna take a second. Okay, let's deal with the exponents first. A is easy. It's a 3. It's a 2. Because 6 divided by 3 is 2. Yeah, we gotta pay, the index has changed. No, I'm totally with you. The index has changed. Okay, I'm never gonna make 1 divisible by 3. It's never gonna happen. So for sure, I know there's at least a C under the radical. So we dealt with the A, we dealt with the C. The C's stuck. There's nothing we can do with him. Even if we did circle buddies, like there's only 1 C, we need 3 in order to actually leave this place. So no, it's not going to work. What about that B to the 8? Yes. So what I would do is I would think like Paige and Gilberto, and I'm thinking B to the 6, B to the 2. Because again, 8's not divisible by 3. But there's a number lower than 8 that's divisible by 3, and that's 6. 6 divided by 3 is 2, so that's why b squared comes out. 2 and 3, they're never going to go together, so that's what stays at home. But if you don't understand that logic, again, you can always try with the buddy system. 2, 3, 4, 5, 6, 7, 8. Now, it's annoying to list out 8 b's, but I need 3 in order to have matches. So 1, 2, 3, I have 1 match coming out. Or 1 set of matches. 1, 2, 3, I have another set coming out. That's why it's b squared. And then there's 2 b's left. That's why there's a b squared left under the radical. So either way, I'm getting a b squared coming out and a b squared left under the radical. Okay, so we dealt with the a's, b's, and c's. Now to deal with that cube root of 24. And you can have another point, Jax. My gosh. So 8 times 3 is 24. I'm going to write that over here. It's ugly, but I'm going to write it anyway. I know the cube root of 8. It's 2. So I know a 2 comes out. So 2a squared b squared. Cube root of, I'm going to move the 3 to the front. 3b squared c. So the b squared c, a squared b squared, you were good with. Cube root of 8 is 2. Cube root of 3, we're going to leave under the radical. We don't know that. Again, Jackson has his perfect squares and perfect cubes down. If you're not like Jackson, you don't have that down. Why is my paper so twisted? Why am I writing so crooked? Okay. If you don't have that down, no big deal. Again, if Seth wants to, he can go to a factor tree
He understands he needs 3 of them because his index is 3. He's got 1, 2, 3 2s. No wonder a 2 came out. He only has the 1 3. No wonder if it was left at home. So regardless, Seth can totally handle this. He might have to circle buddy it. He might have to pull out a prime factor tree, but he can figure this out. It's not that deep. Okay, let's go to number 4. The A is easy. A to the watt power. Yes, because 24 divided by 4 is 6. So the A is easy. The B is not easy because 13 is not divisible by 4. But you could go down 1. Yes, Karen, you can have a point. So if we made it B to the 12, B to the 1, that's the same thing as B to the 13. And then I know 12 divided by 4 is 3, so it's B to the 3 with a B left. But again, if I'm picking on Seth today, he doesn't care. If Seth doesn't understand that, he can still list out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 B's. He needs 4 of them in order to have matches. So he's got 4 right here. He's got 1 match. He's got 4 right here. He's got a second match. He's got 4 right here. Oh, he's got a third match. He has 1 guy left over. He had 1 guy left over. So he can still get B to the third B, even if he doesn't understand backing down to 12, because 12 is divisible by 4. So we dealt with the A's, we dealt with B's, now to deal with the 16. Go ahead, Jax, handle it. It is 2, because 2 to the 4 is 16. So 2 is going to come out. Only the 4B is left under the radical. And so I have 2, A to the 6, B to the third, 4th root of B. Now I have written something wrong and it is intentional. Can someone please fix it? Yeah, and so many people last period came up here to show me their checkpoint was done and they wouldn't have the same index as the problem. If the problem has a 4, your answer needs to have a 4. Otherwise, you've changed it to square root and your problem was not square root, and you can see how on the next test that would get you counted off. Okay, we're not going to rationalize the denominator right now. I think that's good. I just need us to practice that. If you want to do the guided practice ones, you can. I'm just saying we're not going to grade that. All I'm going to grade today is this checkpoint. Oh, Ellie, come get some for your group. Seth, come get some for your group. Angel, come get some for your group. Can you, what? No, you can bring it here and put it in my pile of stuff, yeah. Jax, can get some for your group. Excellent.
And in your poster, if you want me to.
Just lay it on top of the house. Here it is. And then Cooper, since you're already here, you can put it in my pile of stuff. 1, 2, 3, 4, 5. Okay, only one person from each group has to come show me the answers that you have it all done. And you don't have to do number 5, cross it off. Thank you, Ellie. You don't have to do number 5, so it's just 1 through 4. But again, if Ellie is the only one at her group actually working on it, Ellie's the only one at her group who's actually going to get points for it. Ellie can be the designated shower, but if everyone's not working, they will not get their points. Okay, that is all.